now we have parallel lines using the equidistant method. This one's a little bit more complicated than the rhombus method. So if you're ever asked to construct a pair of parallel lines and you're not specified which method to use, the rhombus method is the easier of the two and it's the faster of the two. Why in the world do we have to do the equidistant method then, Ms. Chan? Because knowledge is power. The more we know, the more we can do. We like to have options. All right, so let's think about the word equidistant. What does that word mean? Same distance. Okay, so we understand that. Equal meaning same distance. Okay, so once again, we start off with the same condition we started off with before, which is we have a line segment. And we have a point P not on that line segment. I'm going to extend this line segment a little bit. First thing you guys need to do, let me back up a second. When I first talked about equidistant, that word always implies along what line? Thank you, Javier. It's always along the perpendicular. So guess what we're about to do with point P? Make a perpendicular through point P. How do we do that? We just had a quick check problem on that today. I put the center of my compass on the point. Does it matter if it's on the line, Ms. Chan? Nope. Off the line or on the line, because you have both questions on your construction test tomorrow. Either way, if it has to be a perpendicular through a point that's off the line or on the line, you're going to put the center of your compass on that point, and you're going to create two intersections. So even if it's on the line, you still have to create two intersections. So if point P was down here, you'd put your center of your compass down here, and you'd create an intersection here and an intersection there. So understand that right now. Point P is off the line, so I created two intersections, in which case now I need to bisect that distance. So I can use any radius setting greater than half of the distance between that intersection to that intersection. Does this appear to be greater than half? Let's be on the safe side. Does this appear to be greater than half? Yeah, so I'm going to use that, swing that arc, and I'm going to repeat that from this other intersection. And I have that right there that I can now connect to point P. And now I have my perpendicular through point P. And I'm going to dot the rest of that line below. I only care about that distance, which I'm going to call point R right there. Does everybody see PR right there? This is not a new construction, is it? We've done this before, right? Yeah. I'm going to give myself a point S now. A point S. Anywhere on this line segment here. You can put it there. You could put it over here. Don't want it that close to R. You can put it there. I just decided right there. Anywhere on the line segment, but not too close to R. So now I'm about to show you how to do a perpendicular through a point that's on the line. Again, I said it didn't matter if it was off the line or on the line. In order for you to have a perpendicular, you have to create two intersections. So here we go again. I'm going to call this point S. I'm going to create two intersections where I use point S as the center. Here's one intersection. Here's another intersection. I created two intersections. From that, I'm going to do the same thing I did here. What did I do after I got my two intersections here? I cut that distance in half. So now I have to do the same thing with these two intersections. Cut the distance in half. Does this appear to be greater than half the distance? Mm-hmm. Yes or no?
Yes.
Yes, it does. So swing that arc. Repeat it from this other intersection. And now I can connect this to point S. What do you suppose I have to do next, now that I have this, now I have another perpendicular through a point on the line? Remember, what are we trying to get?
Parallel lines.
Parallel lines using what? So what do you think I have to, what? Same distance. What's the same distance? I need the same distance from point S. What do you think I'm about to duplicate? The length of what? PR. Very good, Ryan. I am now going to duplicate the length of PR. Everybody agree it's set in my compass?
Yeah.
From point S. Creating point T, and what do you now think I'm going to do now? Last and final thing. Connect PT. Draw PT, and what do you think I'm going to have? Parallel lines. Oh. Done. That is the equidistant method.
That's so much more complicated.
I know, which is why I said that at the beginning of the video. This is, if you're asked to do parallel lines and you're not specified which one, this is actually the faster and the easier of the two. This one's a little bit more convoluted.